Good morning, this is your Stats Sensei, Mr. Spensei, and this is a warm-up on one sample proportions. So there are more than 161 million registered voters. That sounds like that's probably our population, so that's pretty important. In the United States, 2 months before the election and the campaign for president of the United States, polling indicated that 54% of the population favored the new candidate. All right. So it looks like we have a claim or historical of 54% or 0.54. So that looks like that's our claim. However, candidate, the new candidate made some unfortunate remarks 3 months prior to the election. 1 week before the election, a random sample, good, of 1,263. So we know our sample size is 1,263. Showed that 634 voters were in favor of the candidate. Since we haven't talked about proportions, I'm just going to underline that for the time being. We'll come back to that in a moment. Does the data support the conclusion that there was a decrease? That's an important, don't know why that's not even highlighted, but we have a decrease in voter support for the new candidate after the unfortunate remarks were made. Test at the 1%. Okay, so we know we have an alpha equal to 0.01 level of significance. Highlight, underline, and or circle the information that you think may be important. We kind of did that. In space, list and label the important information that you think might be important. All right, so we have a claim of 54%. Now that's interesting, all right, because this is the first time that we've ever had a claim as a percent. Um, they're saying the true percentage is lower because of the word decrease. All right. We have a random sample of 1,263. Alpha is 0.01. We said all of that. And we have 634 voters currently supporting the candidate. And that's after the unfortunate remarks. Okay. So let's consider these formulas that we've had before. We have x bar minus mu s divided by square root of n for t. And for z, we had the same thing, except we had the standard deviation of the sample here for the t and standard deviation of the population for the z. What information are we missing? Well, let's to run either one of these. One, I don't see a sample mean up there. All right. Now I have sample sizes, so we know what n is. So we know n is six. We know that n is 1,263. I don't see a standard deviation. And really, I don't even see a mean. So here's what we know we're missing. We're missing the sample mean of X bar. We're missing the standard deviations S, or the standard deviation of the population. And really, it looks like we're missing mu. Now, we can say that, hey, there was a claim. They're telling us we have a claim of 54%. So that's almost the same. So I'm going to go ahead and leave that on the same line and not say that they're missing. But we need to note that we don't have an average, we have a proportion or a percent. But anytime you see proportion, think percent. Anytime you see percent, think proportion. And really, we're missing a population mean. So really, we don't have much of anything necessary to run a standard t-test or z-test. And that is how we are going to have a lesson today on running one sample proportions. All right. Appreciate you watching. Look forward to seeing you on the next one. Thank you.